Hello scholars, welcome. Mr. Hinkle here, continuing our discussion of plate tectonics and going deeper into plate tectonic boundaries. In this lecture, divergent plate tectonic boundaries. So our objective is to define and explain the concept of divergent plate boundaries within the context of plate tectonics. And quite simply, it's this. It's this. We have two tectonic plates that are moving away from each other, and I believe that's our definition. Lithospheric plates move away from each other at divergent boundaries. Lithospheric plates, types of crust, I explained this in detail in my physical layers of the Earth, but there are two types of areas where this happens, and this makes sense. Okay, so there's two types of crust, continental crust and oceanic crust. And we can have a divergent boundary in the middle of a continent or in the middle of an ocean. So, the middle of a continent is called a continental rift, and the middle of the ocean is a mid-ocean ridge. In the middle of a continent, it's going to look like this. So, we're talking divergent, and we're looking at a continental rift. Key terminology, so important, we write it on the board. Okay, probably something to know. So here we're going to say we've got continental crust. That's happening. Well, movements in Earth's mantle will drive tectonic forces. And this movement causes a thinning and a separation where two plates start to move away. What happens is as this plate goes that way, or this side, as the tectonic forces start to spread and thin, we start to get a rift valley form. And then some volcanoes will also form. And our whole goal here for plate tectonics is trying to understand, why are volcanoes where they are? Why do we have mountains where? Why are the continents where they are? How do ocean basins form? What are the processes driving the movement of heat? Why do volcanoes even erupt lava? Plate tectonics explains it all. But it's deeper than that. Plate tectonics has tectonic boundaries where specific processes are occurring. So a continental rift is a divergent boundary in the middle of a continent that thins and can split a continent into two pieces. Some examples: the East Africa Rift Zone. The Red Sea is a divergent boundary. The Gulf of Aden is a divergent boundary. These are young, but they're splitting the Arabian plate from the Indian plate from the African plate. This is called a triple junction. There's a few of them where you have 3 points of tectonic boundaries. East Africa is being split right now. You've got some lakes opening up, some volcanoes around, the volcanism associated with the spreading and the thinning of the crust. And here's probably a little bit better. Magma rises, a rift valley forms, divergence occurs, and you get this kind of a feature. You can go to the East African Rift Zone and actually see the Earth pulling itself apart. This is the beginning of a new ocean. We also see continental rifts. This is would be considered technically a narrow rift, but we've got broad rifts here in the southwest of the United States. We call this the Basin and Range because of the type of topography where the rifting creates uplifted blocks and down-dropped blocks. Horsts and grabens. And basically, as the extension occurs, the blocks form faults. Here's a normal fault and here's a normal fault. Series of normal faults that give us basins and ranges. So the basin and ranges is named aptly after the structure of the landscape. But as the San Andreas Fault drags the North American plate in one direction, and then we have movement in the other direction. Extension is occurring here, and that extension has created the basin and ranges. So, broad type of continental rifts. Let's say this continues, and it does. Over geologic time, now this rift is going to get so thin that what happens is now we have oceanic crust that is being fed by the mantle material. It's connected passively to the continental crust, and that's okay. But what we formed here now is a mid-ocean ridge. And these line the center of the Earth like the seams of a baseball. Rock from the mantle melts. It erupts in the middle of the ocean as basalt because of magmatic differentiation that's occurring within the magma chamber. It's a really cool process. And this material, here it is, makes its way outward, and it pushes the ocean in one direction, and it pushes the ocean in the other direction, giving us two different plates on either side. This is a plate tectonic boundary, a divergent plate tectonic boundary. And we can see this. This is the Mid-Atlantic Ridge as discovered by Marie Tharp in her groundbreaking map of the ocean floor. It runs the length of the Atlantic Ocean, and then ta-da, Iceland. Iceland is cool. I've never been there, but I really want to go. Have you? Let's go. That could be us, holding hands in the middle of a divergent plate boundary. So, this is a mid-ocean ridge, except for the volcanoes have grown up so high that they've reached the surface. Iceland is a huge volcanic island. That's why it can source the majority of its power from geothermal heat, because the whole thing is built on a mid-ocean ridge. See the mid-ocean ridge coming up, and then boom, Iceland. It's really awesome. When we look at the global distribution of divergent plate boundaries, here's Iceland. Here is the Mid-Atlantic Ridge. It wraps around through the Southern Ocean. The East Pacific Rise comes up until it reaches the San Andreas. It continues through the Southern Ocean to get back over here. Just for context, around the Pacific is the Pacific Ring of Fire, a line of convergent boundaries, although we do have a little bit of divergent boundary here, feeding the Juan de Fuca convergence over here on the North American plate, and a little bit down here at the bottom of the Nazca plate. Anyways, all of this to show that divergent boundaries are very important. It's where new oceanic crust is created. It's where oceanic islands can be generated. And it is a driving force for tectonic activity that helps to redistribute the locations of the continents on our Earth, and also is important for splitting up supercontinents, because there is a cycle of supercontinent development every 500 million to billion years, the latest one being Pangea, where all the continents come together through subduction, and then divergence breaks them up and redistributes them around the globe. So this is Divergent Plate Tectonic Boundaries. Thank you so much, and I will see you again.